Cool, so hey, I'm Kirk. This talk is not about where I work, so it's kind of about what I do at work, but we don't use any of the technologies that I'm talking about today, and I just wanted to cover whether stuff could be done DIY. Is it too loud or too quiet, my voice at the back? It's okay. How about if I'm here? Still okay? Cool. So you got a great idea, and you want to meet the needs of your customer, and you understand your customer well, so you spin up a software development process. You're like, we're going to build the perfect app for our customers. And then you release it to a web server, and some beta users try it out and validate your concept, and you're like, right, we're ready to go. Let's get this into production. All right, well, it can't just be a web server sitting on the internet, so you better stick a firewall in front of it and call that environment production now. Is that good enough? Well, if you're processing credit card transactions because you want your customers to pay, then you're probably going to have to put a web application firewall in there to monitor for malicious traffic coming in. You'll have to have egress filtering and a proxy for outbound connections to APIs. And you need to run AV on your servers. And then you probably need like a config agent to make sure your server's configuration is correct. You might need an intrusion detection system, data loss protection to make sure no data leaves your environment, identity and access management. And then all of those things produce events. So you shuffle them out to a logging system, SIEM. So is everything secure now? Well, what about the way you built your software? Did you build it securely? So you might need to give your developers security training. Is this thing in the way? You might need to get some security reviews done, maybe some threat modeling. Maybe you want to run some static analysis over your code or some dynamic analysis, or maybe even one of this newfangled interactive analysis of your code, which tests it for security issues as it runs. And you might even do some internal security testing in your team. And now you're pretty sure that your application is secure. You might even put runtime application self-protection in there, which is a module that runs inside your app and looks for security issues. Is your application secure now? Yes. Oh, but someone said, how do you harden your OS? So like, oh, I guess I have to write down how I do that and actually do it. How do you manage patching on a regular cycle? How do you check for files being changed on your web server if someone gets in? How about identity governance? Like you've got a management system for giving people accounts, but how do you make sure that the right people have the right accounts according to their role and they get taken away when they leave? And how do you make sure the whole thing has configuration management? Like, you know, what's your process around deploying new stuff into your environment? Cloud workflow protection. This is the new hotness for Xero and Amazon, where you're deploying stuff in the cloud and it's spinning up and dropping down, and the old approaches don't work. App release automation. So when you build your app, you can get it through to production automatically without, you know, building it on a developer's desktop and dragging and dropping onto a web server. And all this stuff is generating events, and you need to look at them, apparently. So you need to set up a monitoring system. So now it's all secure, right? But someone says, well, can you prove you're doing it? And you're like, okay, I guess I've got to write some policies to demonstrate what we're trying to achieve, and then some standard operating procedures to show how we're achieving it. And now we're secure. Like someone can come in, a customer, and they'll go, are you secure? And you'll go, yeah, look at this. And they'll go, well, did you get anyone external to validate it? Did you run a vulnerability scan? Did you have someone external review your Azure config and your AWS security groups? Have you had any penetration testing done? And what actually happens when an attack comes in? You're like, okay, I need to deal with all of those. Now I'm secure, right? I mean, you had this idea for a customer app, and all you wanted to do to get it to production so that they can pay you $5 a month for a to-do list app. And this is what you need to do. You need to build it securely, you need to host it securely, and then you need to get external verification to show that it is secure. And That's expensive. Oh, I didn't scientifically calculate that. I just liked the number 42. And I thought 42 million was probably a little bit too high. But you know, it's expensive to make your application secure and host it securely and to do everything right, according to the experts. But at this point, we're pretty sure that we've got a secure application. If anything goes wrong, we'll detect it in our monitoring. We'll be able to release changes. But what if bugs happen after we release it? What do we do then? If you've got that WAF that you need for PCI, that might stop some of the signature-based attacks, like cross-site scripting. If it matches a regex, it might get blocked. But what if there's business logic bugs? Like, what if you go to the checkout and you put a negative number in the quantity and you end up refunding customers? Like, the WAF's not going to stop that. Or what if this user is supposed to see the administration section, but that user, if they change the URL, can see it? I mean, nothing automated is going to find that. So you needed to do a new app release if one of these business logic vulnerabilities is found. And you need to do it fast, right? You need to be able to zip around that SDLC, deploy as quickly as possible. But that's expensive. Like, your team has probably moved on. They're probably onto the next best thing. I guess after to-do list apps, it's probably photo sharing or something like that. I don't know. And you need to divert them from their project. They need to make a branch for the hotfix. They need to merge the changes. They need to build it. They need to test it. They need to go around that loop, go through the change review board, and then release. And you know, that could take up to, how long in your organization? A day? Yeah. A month? So, you know, what's the time frame from when someone contacts you and says, hey, we've found cross-site scripting on your site, and someone's put, I don't know, what's not offensive? Someone's put Jacinda Ardern's face all over your website. She's not offensive. It took me a while to think of something that wasn't offensive. And they've put that all over your site, and you're like, oh yeah, it's going to take us a month to change that, sorry. So you probably need to shortcut all that process and get the release out faster than that. So it probably involves like Fred logging into the web server and just manually changing a file because the release process is too slow. At which point you think, why do we have this release process if we only use it when things are boring and not when things are interesting? And you might not even have the source code of your application. Like you might be running, I don't know, an application that was built in Delphi in 2001. It's still running, it's still business critical. So, you know, sometimes you can't even release the application. So the discussion we're going to have today is it possible to patch the issues without touching the website? And I first got interested in this when I was working in a security team, and we would find issues or get notified of issues, and we'd want to fix them quickly, quicker than the developers could. And for some things, that's possible. So, you know, like we can change firewall ports quickly. We can, you know, maybe do stuff on the WAF to block certain signatures. But if it needs an actual code change, it's quite hard for us to change that quickly. So what we do is replace the WAF with a more capable layer. That's kind of a motive. But I made this proof of concept, which I called Let Me Secure That For You, which I'll show you today, which is basically adding some extra stuff into that layer as inbound traffic comes in to prevent the exploitation of a known vulnerability. So what is virtual patching? Well, as I said, it's preventing the exploitation of a known vulnerability. I would say it's an agile approach in that you can do it faster. Like it's the old version of agile, not the new version, where you have to stand in huddles and stuff. And it's available to security teams in lieu of software development. So try not to refer to my job too much, but you know, like sometimes the security team wants to react faster than the Delphi developer who built the thing in 2003 can find the source code. And yeah, you want to react quickly and then let the software development process release the proper version and then remove your virtual patch. So the approach that we use is to understand how to exploit the security issue. And so sometimes you'll need some collaboration with the person that's found the issue, or an in-house, or maybe get your pen testers to help you figure out. We only patch known vulnerabilities or weaknesses, so we don't basically just layer a bunch of regular expressions over the top of everything and hope that stops every security issue, because that way leads to pain. So only do things that actually block known issues, and only focus on that one bit that has the issue. So what technologies can we use to do this? So if you're running a proxy layer in front of your app, most people have some kind of load balancing. You know, once you get more than 3 users of your to-do list app, you're going to need another web server. Proxies like mod proxy and Apache or HA proxy can do things like modify cookies or add headers or block countries, but they can't detect SQL injection or modify HTML to remove some stuff that the user's not supposed to see, or they might not be able to modify the requests, track the users and their actions, and those other things. So you want to add a second layer behind your proxy. So typically you'll add a WAF, and WAFs are good at detecting signature-based things like cross-site scripting and SQL injection, typically with regular expressions. We'll talk about that. They might be able to add CSRF protection, but they probably won't be able to do anything application-specific. Some of the more advanced WAFs can do some, but you know, tracking who is the user that's logged in and what is their role, and therefore are they allowed to see this or that. I mean, that requires application logic, and the WAF is more of a generic device. And they tend to be blockers, so if an attack comes in, the WAF would block it rather than neutralizing it. So your third option really is to write code. And luckily these days, a lot of security people have come out of development backgrounds, and so are quite comfortable with writing code. And so we'll be in meetings with the developers and going, I don't understand why this security problem is hard to fix. And you know, isn't it just an if statement? If the user is in this role, then blah. And the developers will go, well, you need to understand we have dependency injection, and then that needs to inject the user role factory, and then the user role factory talks to the container that talks to the, you know. And so sometimes, you know, a simple bit of code might be easier than the proper way to fix it. And then you have to decide how you're going to react. So are you just going to alert so that people know that there's an attack underway, but you don't block the traffic or stop the attack? Do you want just a blocking page that says you are bad? Do you want to redirect the user to a friendlier page telling them what to do differently? Do you want to transform the requests so that instead of blocking them, you're giving them, oh, that's all good. Instead of blocking them, you're changing their request to make it safe. 2 of my kids have laryngitis and 1 has a croaky throat. I'm really hopeful my voice is not going to run out. And validation, you know, maybe you want to add extra validation so users can't enter, I don't know, script tags in their first name or something like that, but give them a friendly error message in the page rather than just blocking them. So that's our grab bag of different approaches we can use. And here's the proof of concept. You can check it out on lmstfu.com. Let me secure that for you. It's what I class as proof of concept code. I wouldn't deploy it in production, especially as I did an NPM update and it stopped working, so I had to roll back to an earlier version. So basically what the proof of concept is modsecurity, which is a free WAF product, open source, which sits inside Apache or Nginx or IIS. Node.js, where you can write code, and then Redis to store state. And so this is a pretty cheap layer to put in between your user and your application. Pretty cheap as in no licensing costs, and pretty cheap as in you can probably tune it to have reasonably high throughput. And that means that requests from the user will go through this system, and you'll be able to modify it or block it. and then responses from your server will go back through it, and you'll be able to transform them if you need to. Okay, I said a word that a few of you might have been triggered by, and that was that WAF word. Hands up if you've had a bad experience because someone put a WAF in front of your application. Wow, okay, I was expecting the whole room. Okay, I've had heaps of bad experiences with WAFs because I'd build an application and deploy it, and then someone would flick a switch in the WAF and my application would stop working halfway through a day, and we'd spend ages debugging the code and finally figure out it was because someone changed a setting. So developers typically hate WAFs, and the normal approach is to bring the WAF and turn everything on and go, oh no, there's 10,000 alerts, and then turn the whole WAF off. And so, yeah, or if your sysadmin or security teams are real hard asses, then they'll turn everything on and then it'll trigger all the blocks, 10,000 blocks a day, and they'll go, well, we have to block those. Those are security events. So yeah, we're not going to do it that way. What we're going to do, if you remember from the earlier slide, is only patch known vulnerabilities or weaknesses. So we're only going to turn bits of the WAF on if we have a pen test or if we have some knowledge of an issue on a particular page for a particular parameter. Let's look at a vulnerable website I prepared earlier. So just architecture diagram so that you guys respect me. The top one is the original website running on port 5000 on my local computer, where the user, that's me, talks directly to the web server, that's my computer, and we're going to put the WAF stuff in between, okay, and turn HTTPS on. So, yeah, that's running. So this is the website. This is a shopping cart for buying Xero days. It's actually just Metasploit module names and descriptions, but if you're willing to pay $120 for something you can get free in Metasploit, that's fine. And you can come in and go to a shopping cart and enter your details and create an order and whatever, enter your credit card information and buy it. You can sign up. So sign up as me. Yikes, that's a strong password. And once you're signed in, you can look at your previous orders, which I have none, so I'll just quickly create one. Oops, sorry, resolution's a bit lower up here. Thank goodness for autocomplete, eh? Cool. Oh, great, autocomplete on credit card stuff. This is a really good credit card number. Feel free to use it on your own time. And yeah, my payment has been authorized. I review my order and click place order. Cool, and now on my orders screen, you can see my order. So, so I've sprinkled a whole lot of magic vulnerability dust all over this app. And I don't have time to show you all the vulnerabilities, but I'll just show a couple. So it turns out there's a secret admin page, which, you know, I'm Kirk, I just signed up on this site. I shouldn't be able to see it, but I can see previous orders that have been placed. In the shopping cart, I kind of alluded to this earlier, you can put negative quantities in, and the app is quite happy with that. And my friend actually, back in the early days of the internet, got a Lenovo laptop for $1 via a similar bug to this. Placed the order. What else? Cross-site scripting. So when you're looking at one of these things, you can add a comment like, this vuln is free in Metasploit. Sorry, just doing some programming here. And so, you know, the cross-site scripting can do any attack that your program could, that your JavaScript can do. And then there's some more advanced vulnerabilities. So ones that rely on business logic decisions. So, you know, when I'm looking at my orders, I notice that my order has ID 7 on the URL, And so the first thing you do if you are anonymously using a website with authority in a jurisdiction that doesn't have computer crime laws, is you change the URL and go, oh, I can see Joe Bloggs' order because his is ID 6 and mine is ID 7. That totally wouldn't happen on a real website. And then the other issue is that when you're on this shopping cart site, you'll notice that as I go from page to page, the URL changes. So I'm on step 2, entering my entering my details. But what if I just skip step 3 where my credit card gets authorized and go straight to step 4? Oh, confirm your order. Please review your order before submitting. Place order. And my order worked even though there was no credit card. Okay, that actually didn't work, but let's do that again. Oh my God, who put that on there? Clear cut, let's do a fresh one. So yeah, I mean, you can believe me that I know how to write a vulnerable website. Not quite as good at writing a secure website, but we try. You know, so here's a credit card screen and I can skip past it. And that's the kind of vulnerability that only someone that understands how your app works would understand how to fix that or even understand that it's an issue. So there we go, paid by credit card, empty. Chances are your shipping team will still ship that Metasploit module to you. Cool, so that's my vulnerable website. Got a bunch of issues. Some of them are more simple OWASP top 10, and some of them are business logic issues. There's some more that I didn't cover. So as well as cross-site scripting, there's SQL injection, and you know what SQL injection is? Cool, I'm going to pretend you do. So SQL injection is when you get their web app to run your own SQL commands against the database instead of the ones the developers intended, and so you can pull out the contents of the database. Cross-site request forgery, credit card disclosure, password weaknesses, etc. So let's figure out how we can secure that for you. So the bits we're going to put into our grab bag is mod security. Mod security by itself doesn't do a lot. It just kind of sits there waiting for you to do stuff. And the OWASP core rule set is a bunch of signatures you can drop into mod security to get it to do stuff. It's quite a cool project. And both of these projects kind of lulled a bit for a few years and are now picking up again. More people are switching back to using them. I believe that Azure's WAF uses mod security in the background. A couple of other big name ones. I think Cloudflare's was originally based on mod security rules, but I think they've rewritten the engine. So, you know, people are picking this up and using it again. So rumors of its death have been whatever, I've forgotten the quote. And then Node.js we talked about. Okay, so this is what my setup looks like. I'm not a Docker expert, but it's basically like 1,000 versions of Linux running all different things. That layer there is just using the bundled OWASP mod security Docker container with my own configuration. That's using the Node official release version 8, and that's just using Redis uncustomized. Okay, so let's just look at what that looks like. No demo is complete without a Microsoft product. So this is Visual Studio Code, which is our editor, yay. So basically how I set it up is I have a mod security Docker thingy, and inside there, for each vulnerability in my pen test, I'm making a set of rules. So forgot to show the pen test. I went to all the effort of writing one. Acme Penetration Testing Company did a pen test, and it's a rainbow. It's so exciting. And so, you know, each of one of them has a reference number, and typically you'll, you know, log vulnerabilities with a reference in Xero or whatever. And so that's the way that I lay out my configuration as well. And so basically each vulnerability, I document what it is and then put the mod security rules that fix it. And then likewise for Node, I'm not going to show too much of this, but basically each vulnerability or each business logic issue I've put in a separate JavaScript file. I won't show too much more of that. So I think I've talked mostly about this. There's 2 current versions of modsecurity. If I'm starting from scratch, if you're starting from scratch, I'd suggest version 3, which is rewritten. It doesn't have all of the weird features that 2 had, but it's pretty good. And if you want to understand mod security, you really need to read lots of documentation because it's a bit of a mind fudge. So this mod security handbook is pretty good. And the reason why mod security is hard to understand is the syntax is really weird. So it was first invented as an Apache module, and Apache modules in the config file only have 3 things they can put in each config directive, and so mod security puts all this stuff into 3 different fields. I'll show you in a sec. When you turn on mod security, it doesn't do much out of the box, so it's pretty safe to just leave it running all the time. The core rule set has a bunch of different attack classes that it protects against. So a lot of the standard WAF stuff, as well as a few specific things for vulnerabilities that pop up during the year. And they're basically split up into 2 parts. There's the stuff that looks at requests to make sure that they're safe, and then there's the stuff that looks at responses, and so that's mostly about information leakage. And then it basically, each time it finds an issue on a request or a response, it adds to a score, and then at the end, it basically checks that against a threshold, and if the request has too high a score, then it'll be blocked. Hey Mike, what time do I finish? What time do I finish? You'll find out, eh? Cool. Sweet. Okay, sweet. And so this is the weird mod security syntax. This is the bit where you're probably going to do a little vom into your hand. So basically you have sec rule, which is to trigger mod security, and then there's 3 parameters: variables, operator, and actions. And variables is pretty simple. That's things like the file name or the path or the cookies in the request or maybe the headers. The operator is how you want to match it. So whether you want to use a read-go expression, string equality, string contains, greater than, less than, stuff like that. These slides are available afterwards, so you can take photos of me if you want. I won't be available afterwards. Then the actions is the ugly bit. It's like 1 parameter to put everything in. And so it's basically this giant string. So you give it an ID that has to be unique. You say which phase of request and response processing it goes in, whether you want to deny or allow the request if it matches, whether you want to log it, if you want to transform the input, such as normalizing it or lowercasing it, and what the message should be. I don't know, it seems totally self-explanatory to me. Yeah, cool, okay, so everyone's got that. So basically that's what you write with mod security. It is a bit weird, but I do promise that after a while, it's still weird. Oh, this is fun. If you're a programmer, you'll love this. So if you want to do and between rules, you put 1 rule and then the second rule, and you put the word chain, and that means this one and that one. If you want to do flow control, you use the skip after construct to, anyway, so let's look at the vulnerabilities that I've got and how we'd fix them in mod security. So I'll just, so I don't have anything running, so just run that. So you'll notice that this is the original version and this is the fixed version. Just switch the image out. This is the exact same website, but with just mod security in front of it. So let's look at the first one. So the first issue was that admin orders page And we've decided that page shouldn't be available to anyone because it was silly. Why did we even build it? But the dev team needs to make a release to get rid of it. So let's just block it in the meantime. So that was that URL, admin orders. And now using modsecurity, we block it. Forbidden. And so that's a reasonably simple security rule, checking the file name of the request, so the path, and then doing a block. And you see I'm just doing it for that exact path, so I'm not blocking anything else on the site. People should be reasonably comfortable that this is safe to do. The second one was that negative quantity. So modsecurity can do regular expressions. So in our shopping cart, we can validate the quantity field has only digits. So let's try that. So this shopping cart lets me do -2, but then the fixed version, interesting, update quantities. I don't have permission to update that. So, that's modsecurity blocking it again. Obviously, that's not a very nice way to block it. And then the cross-site scripting one. So let's look at how that works. The core rule set comes with a bunch of regular expressions that match cross-site scripting. And it's actually kind of hard to enable that only for one particular parameter on one particular page. So I've got links to some information on how to do that. But here, basically, what I'm saying is, when that goes away, the core rule set's rules are numbered and only run those rules for the comment field on that product page. So if I go into a particular product and put a script tag, then modsecurity is going to block that, whereas it wasn't blocked before. Here's how modsecurity blocks cross-site scripting. This is actually from a few years ago. What they did was the people that got the renewed energy picked up modsecurity project and decided to continue on it. And this was what was in the source code. Sorry, this is the core rule set project, not modsecurity. And what they've actually done is reverse engineered what these regular expressions actually do and documented them a bit better. Because, someone had run it through like a regular expression optimizer, and so it was really hard to understand what that's doing. But you can see it's looking for, something loading, magnify, iframe, and it also, modsecurity has a better feature than that, which is called lib injection. And this comes out of a paper that Guns and Butter wrote, which sounds like a really awesome band name. And their number one hit is Towards Formal Axioms of Validation. It's a rock song. So they found that for any regex validation, you could bypass that, and they basically formally proved that that's the case. What they did instead was, the person that wrote lib injection, I think it was Hansen and Patterson, actually parse the input that comes through the modsecurity and tokenize it as if it was JavaScript and look to see if there's JavaScript fragments. And they do the same thing for SQL injection. They tokenize it as if it was SQL. And that seems a bit more reliable than using regexes. So modsecurity has both approaches. So we'll just skip through these because I'm not going to show them, but they're in the slides. Basically how you do cross-site request forgery detection, how you can modify your cookies, and how you can add headers. So all the kind of basic stuff you can do in modsecurity. The core rule set, the goal of that project is to have low false positives. So you can kind of trust them a bit. They do try. But because we're only turning on the rules for individual URLs and individual parameters, it's even better because it's only that comments field that we're checking for cross-site scripting. So the rest of the site's going to keep working fine. Modsecurity is reasonably efficient. It's obviously not as fast as not having it there. And because it's stateless, you can just spin up 1,000 of them in AWS or whatever and pay $7.60 per second. And it gets really complicated. I would say mod security is not the easiest to use. And it can't really understand your program state or modify the HTML. And it's supposed to be extensible by Lua, but it seems like nobody does that. Which is why, when I was putting this together, I was like, I'm going to have to write in another language. Because I want to fix business logic issues. So this is where we get to the Node.js part of it. And here's just a bundle of these are just some of the 160 Node modules that my proof of concept uses, because that's how Node works apparently. Basically a proxy layer, so we go through the mod security proxy, through the Node proxy, and then to the website. And this is how a proxy works, in case you haven't used a proxy before. Request comes in, the proxy layer makes a copy of it, and then sends the copy of the request to the origin server, gets the copy back of gets the response back, copies that response, and sends it to the browser. So basically, it's sitting in between the browser and the server. And then what I do is, for each vulnerability, I make another handler, and there's a what do you call them? Function. For handling requests and handling responses. So each handler basically gets sent the request, it does what it needs to do, it sends it back to the central thing, which passes it to the next handler, passes to the next one, and then it eventually gets to the web server and the response comes back and gets modified the same way. So we did look at more complicated vulnerabilities. So one of them was being able to view other people's orders. So the thing that's hard about this is that your proxy needs to know what orders a user is allowed to see in order to block access to the ones they aren't allowed to see. And so when you're on the application, on that orders screen, I mean, it's showing the user which ones they're allowed to see, 7, 8, 9, and 10, but you need to stop them from viewing 6. And you're a proxy layer, you don't have access to the database, you can't look it up. You have to infer it from requests and responses. So what I do in this example is, when the My Orders page loads, my proxy looks at the HTML and grabs from the response which IDs these links have in them, so 7, 8, 9, 10, and then keeps that in Redis. And then for any subsequent request that the user does, if they look for any that aren't those IDs, then it blocks them. Let's see if that actually works. Then I'll quickly show you the code very fast. So, what was it, 6? So I'm just redirecting them back to order and writing security violation in the URL for demonstration purposes. I mean, the code is reasonably simple. So as I was saying, I have a function for the request handling and then a function for the response handling. And what I do in the response handling is I effectively do a CSS selector to find the hrefs and pull the IDs that the user's allowed to see based on the HTML, shove them into Redis, and then when they come back, okay, so this is bad JavaScript, I'm not a JavaScript developer. When they come back, I connect back to Redis and check if the user is allowed to see the ID that they're trying to access, which is somewhere in here. And if they aren't, I redirect them. Okay, so that was quite fast, but you can look at the code if you want. And the same with the payment step. So what I do here is I give the user a cookie and I track which steps of the checkout process they've been through. And if they skip step 3, then I send them back to step 3. And similarly, I call that step control. Basically, map out which URLs they're supposed to visit in what order, and then redirect them if they don't visit the right ones. Cool. And other things you can do with the proxy, you can manipulate HTML. So that Harman library that I was using seems like it's not that well supported, so I might need to pick something else. Lets you do nice kind of selector style syntax to match the HTML as it streams through your proxy. And this is turning autocomplete off on password fields. It's a pretty uninteresting vulnerability. This is a PCI compliance one. It's not really, it's just a regular expression, or this one's just blanking out credit card numbers and responses. But you can do basically anything you can write in code, you could do in your proxy layer. So something that we do a fair bit is tamper protection, so making a hidden field so that it can't be tampered with, because often people assume that if a field is hidden, then it's secure. So why should you use Node? I don't know. I used it. I just wanted to. Yeah, I think that Node proxy is reasonably well used and supported, but the layers on top of it that I used may not be. But I think it's kind of hard to program JavaScript. And the thing is, like, you can't use Node or a programming language without using modsecurity, because you need all those signatures. So each time you have a vulnerability, you have to pick which layer you're going to fix it in. So that's, is that my talk? Yeah, I think that's pretty much my talk. What I wanted to show you was that virtual patching is a thing. So just like in a firewall, how you can, I don't know, block vulnerabilities on ports, you can do that for websites as well by rolling your own proxy layer in front and writing code in it. It's another tool you can add to your tool belt, so your security team has something they can do in these situations. And you can set up the infrastructure in advance so that if you have an issue, you have a Docker setup or whatever that you can just put behind your load balancer in front of the application. Or maybe you could leave it in path all the time if it performs well. And it really fixes our problem we had. Like, we could build our stuff securely, and we could host it securely, and we could verify it was secure, but we couldn't react quickly because of that turnaround time. And so this is basically one approach to let us do that. Just in case you go home and do this yourself, remember not to turn your WAF on, like turn everything on, such as the path to the dark side or something. Only turn on the bits of the WAF that you actually need for vulnerabilities that you actually know about, or you will go mad. And yeah, that's my talk. Thanks very much for attending. Cool.